Okay, if you have a wave and that is one source, this source is generating wave like this. So how many wavelength from this to this? We have one,
We have one,
two,
two,
three.
3.5.
Yeah, 3.5. Okay. And let's say there is another wave and that is generating up like this. Okay.
Yeah.
And that is also placed over here at the same place. Okay. So,
Oh, that, I get it now.
okay, so these two waves will be in phase. Now, let's say I move this source a bit forward up to this.
Yeah.
So the phase difference between this wave and this wave is that is half, lambda divided by 4.
Yeah.
So there is the phase difference is lambda divided by 4.
Which is pi over 2.
Yes, which is pi over 2. So what do you think? Is this source will be coherent?
Yes.
Yes, it will be coherent, okay? Because there is a constant phase difference on all the way, and that is lambda divided by 4. Yes, lambda divided by 4, okay? Okay, so these wave will be coherent. And what do you think? What do you think? If I combine this wave with this wave, so it will give me constructive interference or destructive interference. Both are coherent. It will give me constructive interference.
Yeah.
No, it will give me destructive interference because the phase difference is in the fractional form.
Oh yeah. You're right. I told you the phase difference has to be pi over 2.
Yes.
Lambda over.
Yes. So
But
that is
here
lambda over 2 or 3 lambda over 2 or 7 lambda over 2. So that is.
But here you wrote lambda over 4. Here you wrote lambda over 4.
So that is pi divided by 2.
Oh yeah. Okay, fine. Okay, draw another wave that is not coherent, so I can see the difference between coherent and
Okay,
non-coherent.
wait. First we need to finish the coherent.
Okay.
Okay, so if I move this way, it's not moving. Okay, if
I get what you're saying. I get what you're trying to explain. Just say.
if this will come over here, okay, then it will be coherent. It will no both sources are coherent, but this will give me because the phase difference is 0. Phase difference is 0, so it will give me constructive interference. Okay, got it?
Yeah, I got that.
Okay, so if this is this will be the coherent light source, and let's say there is another source, okay, which generating wave like this. So there is the phase difference between these two waves are not constant. It's varying. Here the phase difference is 0. Here there is some sort of phase difference. Okay. Actually, I did.
That's because the two waves are different frequencies.
Yeah, two waves are different, have different frequencies. But frequency will not be constant in this wave.
Yeah, so they both have different.
Because because the phase there is a variation in phase difference. With the passage of time, the phase difference is random. It's not constant. Okay, it's changing.
Oh, okay, I get it now. Thank you.
Okay, wait. I will Google the clear diagram so hopefully you will get.
My exam will be online, so I will call you when I have my exam. If I have any, if I need any help, I will ask you.
So you will enjoy that exam.
No, it will still be timed. There will be time pressure.
Okay, so this is your coherent light, okay, and this is your non-coherent LED light.
Oh.
Got it? There is the phase difference between the different waves is random, not constant. But in this case, that is constant. Okay.
No, I can't hear you.
Hello.
Oh, sorry. Oh my god. I can hear you now.
Yeah. So in this case, the phase difference is not constant. Okay, it's varying. Okay. In this case, the phase difference is constant.
Got it.
Okay. If you have two slits, okay, if this is one light source, so this will and this give me coherent light. Okay. So this is one and I'm going to place two slits in front of this. Okay. And
What's the difference between two slits and one slit? Okay, fine. Explain this. I will tell you later.
okay, actually, two slits means this is one light. Okay, actually, through using two slits, I can generate two sources, two coherent sources. Okay, this will be one source, and this will be another source, and both waves will be coherent waves. Okay, but if you place one source over here and second source over here, then there will be some differences. Okay, so instead of using two sources, we use one source and place opaque objects in front of them. Okay, like this. Got it?
Yeah.
Okay, so this distance is d, and let's say this is slit 1, this is slit 2. So if slit 1 light cover distance d, and if that distance is equal to slit 2 distance d, then you will get a constructor interference. Okay, actually, we studied that this region will always be bright one. Okay.
Oh, yeah, I don't understand why.
Actually, the distance, okay, distance is constant. Distance from this to this is same as the distance from this to this.
Oh.
So that's why your
There will be
lambda,
double.
yeah, your lambda will be equal to lambda of source 1 will be equal to lambda of source 2. So you will get a constant light. But here you will get a dark light. Here you will also get a dark light.
What if there's white light?
There is a dark light. The distance will be this, okay? And for this, the distance will be this. So distance covered by S2 is less than distance covered by S1, right?
Yeah.
And if I draw a perpendicular line like this, okay, then this distance, where I will draw it using another, then this distance will be equal to this distance. Now you need to find this distance. If this distance is equal to lambda or 2 lambda or 3 lambda, then you will get bright light over here. But if this distance is equal to lambda divided by 2 or 3 lambda divided by 2 or 7 lambda divided by 2, then you will get a dark light. And this will be equal to lambda divided by 2, any value of this, because we get dark region over here. Then after this, we will get a bright, then dark, bright, dark, bright. But if you but if you move in this direction, then your intensity will get decreased. Or if you move in this direction, then the intensity of the light will get decreased.
Yeah.
We studied this last time, and you said that you have.
Wait, does this? I have a question. Does this occur for all types of monochromatic lights, or is it just white light?
No. Actually, in monochromatic light, you will get only one type of light. That's depend on this light source. If this light source give you red light, then here you will get, instead of bright, here you will get red light, then dark, red, dark, red, dark, red, dark. But if
how will the intensity look? How will the intensity look here? Will it be like this?
Yes, here you will get more. Here you will get dark red light. Okay.
Or intensity like that?
Yes. Then the intensity will get decreased.
So like that, and then like that.
Yeah. Yes, the intensity will get decreased. Yes,
I don't know.
yes, it will decrease like this.
Okay, fine.
But if you are using white light, then you will get a range of light over here.
Yeah, it will be
Actually,
one.
the main point which I want to verify you is this one, okay? This one.
So
Okay,
this can be used to find.
that either your fringes will be bright or dark. You will get dark. Okay, if question come like this, that this distance is given to you, okay, and the question is like find point A. Either point A will be dark or or bright. Okay, so what you will do? Let's say
We
this.
put.
Let's say this. Wait. Let's say this distance is given to you, and this distance is also given to you. Okay. Question is find the point A that either that will be dark or. So you will draw point like this. This distance is given to you, that is 4. This is 6. So you can find this as this will be a triangle. Okay. Then from here you will draw a perpendicular line. Then you need to find this. If you get this in whole number, okay, then it means this point will be the brighter. You will get a brighter.
No. It has to be a multiple of 2. Wait, no. Sorry, no. Wait, how do you find out if it's bright or dark? I don't get it.
If this is either equal to lambda 0, and it will not be 0, okay, either equal to lambda 2 lambda, 3 lambda, 4 lambda, then you will get bright light because there
How
will
do you know?
because
How do you
they,
know?
because
How do you know? Sorry, how do you know what lambda is?
you need to find this distance. Okay, you will find this okay, you can find it like this. This will be you equal to 6 square plus 4 square root by using Pythagoras theorem.
Yeah.
So you will get this, and this length will be equal to this length. Okay, and this distance will be given to you. Okay, let's say that is 5. So 5, this will be equal to, this whole length will be equal to 5 square plus 6 square root. Then this distance will be equal to this minus that.
Oh. Okay, I get it. Thanks.
Yeah, so but if that is in point, okay, in point, then you will get a destructive interference. Okay, and why you will get constructive and destructive interference, I explained it. I already explained you this. Okay, if the definition is lambda 2 lambda 3 lambda, then you
Yeah, I
will.
get it. And I have one last question.
Okay,
If here, oh my gosh, wait. If it was just one slit here, so like this is one slit,
then you will get only one wave.
and then if this is just one slit here, how will the wave look in this case? There will only be one gap in between, not 2 gaps.
You
There
will
will
get
only be.
you will get bright light on the screen. Okay, and the intensity of bright light will get decreased, and there will be no dark fringes.
But I thought that diffraction will occur. Look,
Yeah,
when this diffraction will occur, so then there will be destructive interference and constructive.
no, if there is two source, then you will get constructive and destructive interference.
Are you sure? Okay, fine.
Okay, wait, I am going to explain it a little deeper. If you have two sources, okay, actually the there is a terms that use for this. Okay, if you have two sources, okay, then you will get diffraction like this.
This is one source. This is one.
Yeah, wait, and the wavelength on no you there. if this is one, if you have two sources, then you will get then you will get diffraction, constructor and distort interference. If you have two sources, then you will not get constructor and distort interference. So here,
why is there bright?
where,
Why is there bright and dark shades if there's no constructor?
so on this point, you will get constructor interference, then destructive, then constructive, then destructive, then constructive, like this. Actually, I didn't draw it clearly.
Wait, no, I'm sorry I keep posing you, I don't mean it, but look, this is, the dark part is constructive and then the white part here is destructive. Constructive,
Yes.
destructive.
Yes, constructive. Yes, right. That's right, yes.
Okay, now carry on. Now I just wanted to clarify that. Carry on.
Okay, I want to Google this, then you will get.
Oh wait, if there's more than two slits, then there will be destructive and constructive.
Yes, yes.
So if there's one slit, then what happens?
Okay, wait. Diffraction. Okay, look at this graph. So these are the two slits, okay? So on this point, okay, you will get, because these points are in phase, so you will get bright light. These points are not in phase, so you will get dark light. Here you will get bright light. These points are in phase. And similarly here you will get bright light, but here you will get dark light. Here you will get, because there is a destructive interference of this source light and this source light.
Where?
Here.
Okay.
And here. But on this point, you will get bright. On this point, you will get bright.
Yeah.
And your question is, you said that if I have only one source, then there will be dark and bright fringes. Actually, if you have one wave, then how you can say that there will be bright and dark region? If there is another wave, then you will get bright light, and they are in phase. Okay. Then from these two, you will get bright light. Second one.
Yeah, that's true. Oh, this is confusing.
So read the
because
question.
I can't. Look, you know this diffraction and then that wave. What does effective resistance mean?
Effective resistance is simple resistance.
Okay, CL equals current entering junction equals current leaving. Okay, what implication does it have for the charge entering and leaving the circuit? It means that charge is conserved.
Yes.
Next, Kirchoff's second law. Voltage drop equals voltage of source.
Yes. Calculate R1. And voltage across R1 is 2 volt. And ammeter read 3.5 ampere.
That's easy. V equals IR equals V2 over 3.5.
Yes. And that's equal to?
Let me do it.
0.5714.
Yeah.
Calculate R2.
What's R2? It doesn't.
It's too easy.
A to B. I have to calculate V2. Wait. This will be 17.5.
17.5.
5 times 3.5.
Oh,
No.
I did not expect this type of error from you, from Farjana.
Oh my god. How could I do that?
Actually, 3.5 is splitting. This current is splitting in this component.
Oh, I know. Oh.
Okay, find the voltage. First find the voltage, then go toward the current. I give you hands.
I know. I'm trying to find the voltage.
So voltage is simple. Apply KVL.
10.
10 volt, good.
No, but some voltage is going here.
This voltage is 12, this is 2. So you will get 10 volt, and in parallel the voltage is same. So 10 volt across this, 10 volt across this.
Oh, yeah.
Now you need to find the current.
Okay. So 10 divided by 5 is 2. So 2 amps will go here.
Yes.
So 1.5 will go here.
Yes, so 1.5. So that's equal to 100 divided by 50.
Which is 3 5s. 20 over 5. Wait, 20 over 3.
6.66666.
Yeah. Next question.
Calculate the power dissipated by the bulb.
Oh, easy. P equals IV.
Yes, current is.
It will be 2 amps times 10 volts, which is 20 watts.
Acha, the bulb dissipates 75% of its power as heat and convert the rest to light. So this bulb is, I think this bulb is the 100-watt bulb, which people used.
No, just do 0.25 times 20 watts. 0.25 times 20 watts equals 5 watts.
Yes, that is equal to 5 watt.
But the efficiency will be. Oh, the answer is 25%. So easy.
Efficiency is 25%.
Yeah, 100 minus 75%. Sorry.
Actually, efficiency is equal to output divided by input. So output is 5. You get 5 watt. Instead of 20 watt, you get 5 watt. Then you need
3.5 amps times 12 watts, which is, and then we have to do 5 divided by 3.5 times 12. That's the answer, times 100.
So you will get 11.9%.
Yeah.
Good. Yes, you will solve it like this, okay? Actually, when you want to solve question, okay, so write all the formulas over here. So you will get lots of things from that formulas like this. Based on the. So you need to find the total resistance, and that will be equal to R1 plus R2. But from KVL, how you will find it from KVL? Source voltage is equal to V1 plus V2. Source current is IR. That's equal to, because it is in series, so current will be same, IR1 plus IR2. So your resistance will be equal to R1 plus R2. In this case, we will apply KCL, which say that I source is equal to I1 plus I2. So I source will be equal to V source divided by R source. That is equal to V1 divided by R1 plus V2 divided by R2. But it is in parallel, so V is same, so you can take common and cut out by this. So 1 divided by RS is equal to 1 divided by R1 plus 1 divided by R2. Got it?
Yeah, I got it.
2 resistor, this.
What is constant? That's why you cancel it out, right?
Yes. 2 resistor, 1 are connected in parallel, are linked in series to a 3 ohm resistor. All of this in parallel with a 4 resistor. If the total effective resistor is, then what is the resistance of the 4th resistor?
Let's draw it.
Good.
It will be 1 equals. This total will be half plus 1.5. 1 divided by 1.5 is 2 over.
This total will be
2 over 3, right?
Yes, 2 over 3. Good. 3. Yes.
Plus x.
Plus x. But x is in parallel with this combination.
Sorry, plus 3. Then 1 divided by that plus 1 over x.
ये line नहीं आएगा. This line.
So I'll skip this. I'm easy. I just need pen and paper. It's easy.
Okay, it's easy. Most thermistor in LDR program semiconductor LDR resistance. How change in temperature, color, change in resistance thermistor. For an NTC thermistor, will the resistance increase or decrease as temperature rises? Easy. Is it easy? But you need to discuss the reason that if I increase the temperature, then why the current will get increased or resistance will get decreased? What is the reason behind this? You need to discuss that. You have 2 marks. This is 2 marks question. So what you will?
As the temperature increases, more electrons will jump from conduction band into from valence band into conduction band.
Valence band into conduction band. Okay. If there is an electron in the conduction band, then your material will be conductive. Okay. So remember it like this. If there is an electron in the conduction band, then your material will be conductive. So from valence to conductive, not from conductive to valence. Okay. The lower one is the valence, then the conductive band.
You can't go from conduction to valence. You can only go from valence to conduction.
Yes, you can only go from valence to conduction. But if electron go from conduction to valence, then what will happen?
That can't happen.
Then electron will release energy in the form of light. Then you will get a spark.
Oh yeah. Like in the open circuit.
Yes, like in the open circuit. Good.
So more electrons jump from the valence band to the conduction band, therefore
current will get increased because current depends on the number of electrons.
More current will be generated because more electrons are present.
And current have inverse relation. Yes.
Outline the mechanism behind LDR's variable resistance.
Also write the relation in bracket. Okay, so the teacher will get it. In resistor have inverse.
Yeah, I know. A equals B over R.
Actually, write the answer properly. So that why you will get a good mark.
Yeah.
Outline the mechanism behind an LDR variable resistor.
What do they mean?
Light dependent resistor. It is variable resistor, and it is variable resistor if there is a variation in the intensity of light.
Yeah. Well, the mechanism is the same as thermistor.
It will be the opposite.
As the light intensity will increase, then the resistance will decrease.
Yes.
It's the same mechanism.
Yes.
What does the mark scheme say for this?
Actually, LDR means light dependent resistor. Okay. So it depends on light. If there is light, then your resistance will get decreased. If there is no light, then your resistor will not be minimum. Your resistor will be high. So it is same. I think it is same as like the parting. So this is the end of this paper. Let's move toward the next paper.
Yes.
The question is about the variation of quantities such as current, voltage, resistor in simple electrical circuit.
I wonder what questions my school will give in my exam.
Okay, so this will be
state Ohm's law. V equals IR.
Or to assign one of the following component to each of the characteristic filament lamp. Which one will be the filament lamp? Semiconductor, resistor.
That's easy. Easy.
This will be for filament.
Yeah.
Okay, good. You will get extra marks for this answer.
Are you joking with me?
Yes, you will get extra marks. And that extra marks will be 3.
Wait, what are you doing? This is ohmic conductor.
Ohmic conductor this is.
This is filament lamp. This is diode.
Good.
It's too easy. So I was not listening when you were speaking because I thought it was too easy. But then I didn't know you wrote the wrong answer.
Why have?
You tried.
Okay, can you hear me clearly?
Yeah.
Okay, why have these plotted on a graph of current against potential difference rather than current against?
Oh my god. Oh my gosh, you answered this. That's crazy.
And
Okay.
you know the answer of this.
Let me tell you the answer. It's because oh my gosh. Don't tell me I don't know this. Because potential difference is the output. It's the work done by the.
Yes, it is the output actually. Yes. Potential difference. So which component will give you potential difference? Passive component. Yes. So that is actually the potential difference is the voltage across that component, passive component.
Yeah, because this graph is showing relation relative to the component, not the whole circuit. Right?
Why you are bringing this graph in this question? Don't bring this graph over here. They are asking that why have we put in graph of current? Yeah, current against potential difference, current against potential difference, current against potential difference. Yeah, these are the components. Yes, you can say that. This is R, this is bulb, this is diode. Yes. So yes.
Let me tell you what the Marx scheme says. The Marx scheme says electromotive force is concerned with energy being put into the circuit, whereas potential difference is concerned with the energy used by the components.
So energy electron putting into this component, electron putting into this component is the duty or responsibility of EMF. And energy dissipated in this component is the duty of potential difference, or you can say that potential difference will tell you how much energy will this electron will dissipate
by the component.
Yeah, will be dissipated in this component.
So here work done is on the electrons, right? Work done on electrons.
Yes, work done on electrons.
Here by electrons. Work done by electrons.
Wait.
Wait, is it the opposite?
Yeah, I think it should be the opposite. Here the electron is giving energy. So when electron is giving energy, so it means work done by electron. Here we are. Here this battery is doing work done on electron. Yeah, you're right. Sorry, I said it wrong. But you can draw this circuit, okay? But it's only one mark, so just explain it like this. Passive component, instead of using resistor, use passive component and use for the. Okay, don't complicate it. The Marx scheme very, very simple. All the Marx scheme says is electromotive force is energy being put into the circuit, potential difference is energy used by the components. That's it. 1 mark. Yeah, 1 mark, but you can write the work done. That will be the plus point. Yeah, energy, the potential difference is the work done by the component. On the, work done by the, work done by the electron. By the component, yeah. Not by the component, work done by the electron. Yeah, energy used by the component. Yes. I'm talking about this, not that. Yes. Here, electron is doing work done on this component. Yeah. Means electron is giving its energy to that component. That if electron has 40 joule energy, then it depends on the component. If component demand for 40 joule energy, then electron can give that energy. But if component demand that no, I need only 30 joule energy, then electron give that 30 joule energy. It depends on the component. If your resistor is large, then it means resistor demand is large. Yeah, here is this resistance infinity. Yes. But for diode. Yeah. Because backward bias. Forward bias, backward bias. Actually, bias means applying voltage across the diode. For the diode, state the value of the resistance when applied. So that will be infinity. Yes, that will be equal to infinity. Exactly, but the Marx scheme says 0. I think the Marx scheme is wrong. Yeah. Yes. It can't be 0. Yeah,
What is
so it means that your mock scheme is, there is also some sort of mistakes in your mock scheme. So don't depend fully on mock scheme.
yeah, that's true.
Yeah, don't depend to.
It's because this mock scheme is not professional. It's not made by the exam board. It's not made by the company. It's
Yeah,
made by some
actually
random man.
it's made by some website developers. Actually, some people want
Exactly.
to earn money from website. Okay, so they make such type of mock scheme.
That's why I want to do the other paper, because that paper is coming from directly from the company, so they will give proper mock scheme. But let's finish this first.
Yeah, but we have only few questions. Sketch the following resistor against temperature for an NTC. Good. Resistor current against voltage for an NTC thermistor.
Oh, that's a good question.
Yes, constant temperature. Yes. If your temperature is constant, then it will be like this. Okay, and you should write this, okay? Constant temperature.
Yeah, I wrote it, you see.
Yeah. Next part. Okay, current is given to you. You need to find the time. No. Yes, you need to find the time. Electrons is given to you. Yes.
Yeah.
Yes. How you will find the current?
Wait, I'm confused. The mark scheme says something different for the current the current voltage graph for the thermistor. They put like this. They put inverse of the filament lamp, concave up in the positive quadrant and concave down in the negative quadrant. They didn't draw a picture. They just describe it. I think they're wrong. Leave it. Okay, leave it. I think they're wrong.
They, for first part, they write like this.
Yeah, but for second part, they put inverse of the filament lamp. So let me show you. Like that. Yeah, like that.
Okay, got it. Actually, your graph will not be like this. Okay. Yeah, it will be like this for ohmic conductor. And this is semiconductor. Thermistor is semiconductor. There is a point which hidden inside this point, this word that is the semiconductor. So you will draw it like semiconductor curve. Exactly like semiconductor curve, and that should be like this.
What about filament lamp? Filament lamp is like that.
Yeah, that is like this. But for semiconductor, we draw it like this. And filament lamp is not your
semiconductor.
That is the inductor. We will study inductor later on.
Oh.
We have three types of component. One is resistor, inductor, and third one is the capacitor. So in filament, if you see to the bulb, okay, 100-watt bulb. Okay, if you see to this bulb, then there is a filament like this. And nowadays we not use this bulb. Initially, we used this bulb in 2010, around about 2010, 2009. But after that, we get LED bulb, or you can say that we get energy saver. Nowadays, we are using energy saver and LED, but LED is costly, so that's why most people use energy saver.
Yeah.
Instead of using, but if you use LED, then it will consume very less electricity as compared to energy saver, and energy saver consume less electricity as compared to this 100-watt bulb. And so it's more energy. And this is more brighter than 100-watt bulb, and similarly LED is more brighter than energy saver. And also the lifetime of LED is more than the lifetime of energy saver. And similarly, lifetime of energy saver is more than the 100-watt bulb. Did you saw the 100-watt bulb in your home?
No. Actually, I don't think we have.
Yeah, actually, most people use it in round about 2010, 2000 up to 2012. Most people use this 100-watt bulb. And its light is not the white light. Its light is the yellow light.
Yeah, so LED is the best bulb because it has the longest lifetime and the most energy.
Yes, yeah, but there is one negative one, and that is the cost.
Oh, okay, fine.
So this is your 100-watt bulb. This one. This is. Oh, you saw this. Yeah. You saw this type of bulb. As you see.
Yeah, in my house.
Yeah, as you see here, we have number of turns. Okay, number of turns, and this is a resistor wire. Okay, and we use this as a resistor wire so that all energy will be will electron will release all energy in this resistor wire because the demand will be high as we are using high resistor wire. This is not.
Oh.
Yes. Okay, next. Okay, this question. So your curve will be like this. Okay. Actually, when you answer any question, then read question 2 to 3 times. Okay. Actually, there is one point that is the semiconductor. So for thermistors, there is semiconductor. So you will draw.
What type of components are semiconductors?
Thermistor is your semiconductor.
What else? What about LDR?
LDR is yes, that is also semiconductor. Yes, because it also depend on light. Because this LDR also needs this much gap. That is in between insulator and because in LDR or demand is like this. If there is no light, then your resistor should be high.
Yeah, because the electrons will be in the valence band.
Yeah.
What's the charge of one electron?
That is charge on one electron is.
I keep forgetting. Is it?
No, 1.67 times 10 to the power minus 27.
Okay.
Mass of electron is 9.11 times 10 to the power minus 31. Yes, that is 1.67 times 10 to the power minus 27. Yes, I think this is the charge.
Let me calculate.
Minus 19 plus 23.
Yeah, I got it. He equals 1,600 seconds.
Yeah, 1,000. No, 16,000.
No, 1,600. Oh, wait, let me check again.
Okay, this is 22, not 23. Got it.
Yeah, 1,600. Okay, next question.
Okay, this is also easy.
Wait, let me draw it. That's easy. It will be like this. Triangle.
Yes.
Calculate the charge that Q equals IT.
Yes, that is also simple. Okay, you can write it by your own. Later on, you can do it. Okay.
Yeah. Oh yeah, what's the answer for C? This is a good question. C.
Against time, horizontal axis, which of the following accurately describe that what you would have seen? Okay, so linear increase. This is charge. This is time. So your this is increasing. So it means your current is increasing.
It will be I. This will be the answer. Non-linear increase. Let me check the answer.
Okay. I thought we need to draw the graph of each. Okay, we need to choose one in all these three. Actually, if with the passage of time your charge number of charges is increasing. Okay, so if your number of charges is increasing, then your curve will be like this. This is the current. And
how do you know the number of charges increasing over time?
Actually, that is given to you.
Oh, okay. No, it's because charge will always increase if you turn on the power supply.
No. It will not always increase.
Oh.
Yes, charges will not always increase. Charges will remain constant. Okay.
How do you know it will increase here? Go to the part B.
No. Actually, that depends on the battery. That how much charges it will create.
Oh.
Depend on voltage.
I thought it will keep increasing over time until you will stop the voltage supply. Why is it not like this? Like this?
Okay, wait. The charges against time. Abjad has been to record a graph of charge at that time. I could describe that I took care. So the answer in mock scheme, the answer is non-linear increase.
Yeah.
The number of charges.
Go to part B. It links to part B, that's why. So look, here you can see that over time it will be like this. Here will be 30, here will be 0, here will be 30 seconds. So
No,
you can see that the area is decreasing over time.
The great teacher that is transformed in this time.
It should be decreasing, actually. What is this?
Why it okay, so he noted that it decreased linearly from 10 ampere to 0 over a time of 30 seconds. Okay. Yeah, this is given to you.
Yeah, so the area, look, the area is decreasing over time. So if the area is decreasing, charge should be decreasing like this.
Yes, your charge should be decreased like this. So it should be, yeah, so that will be non-linear.
Decrease, it should be non-linear decrease. If the current will be 0 at the end, how is the charge increasing? It doesn't make sense.
Yeah, it doesn't make any sense.
I think they made a mistake. I think this should be non-linear decrease, then it will be right.
Yes, I think it should be non-linear decrease. Yes, it will be non-linear decrease.
Because over time, the area is going smaller, smaller, smaller. That's why. Okay, question 3. Go down.
Okay, so this question is related to this resistor, okay?
I forgot the equation. Is it P equals RA over L? Or
Rho, this is rho.
Yeah, rho equals R.
A over L, yes, good. Okay, R A over L. Yes. R have direct relation with this. Yes, so third is the correct answer.
That's right. Last one's right.
No, not the last one. Third one is the right. R have a direct relation with L and inverse relation with area.
Both is right.
No, both is not the right because this is area, D square.
Oh.
Next. Okay, you can write it easily. It's easy. R is equal to R A, where A is the pi D square divided by 4.
Yeah, pi D square 4 and the R over L.
Yes, next question. You need to find the resistivity for a point which length is given to you, radius is given to you. So it is too easy, okay? You can find it.
How?
You need to find the resistivity. Area is also given to you and R is also given to you. And sorry, L is given to you. And R, you can get R from figure 2. Where is figure 2? Yes, this is figure 2. So you can get R from this. That will be equal to 5.
Oh, okay, got it. That's easy. It's easy. Next question.
Resistivity increase with temperature. As you see over here, or resistivity increase with temperature, that's why the current is decreasing.
Oh.
Okay, because here you can see that the tangent line is decreasing. If it will go like this, so the tangent line will be like this. So you can say slope will get decreased.
Yeah.
Oh, next question.
So as the temperature increases, the current will increase. But then as the current will increase, the resistance will decrease. I mean, the resistance will increase.
Yes.
Because of the and then okay. My next question: superconductor is a material whose resistance increases to infinity below a specific critical temperature, decreases to 0. Can you draw the graph for the critical temperature again, please?
Room temperature is 25 degree.
Yeah, because no energy loss. 100%.
Yes. So if you decrease the temperature of your room, then there will be no energy loss. Got it?
Yeah.
So this is the end of this paper.
Okay.
This is the end of the
Okay, go have your selfie.
Yeah.